Are you comfortable with the static route and default? So routing protocols make your configuration easy. When you know routing protocol, you don't need to write static route.
Yes, sir.
The routes will be dynamically written into the routing table. You don't need to type. The protocol will type it for you. You don't need to see which one is best path. Protocol will decide the best path. I repeat, protocol will decide the best path. Not only the protocol decides the best path, when something goes wrong with the path, protocol will be switching the path to alternate paths, switching the traffic to alternate path. For example, if we will have two connections, one path A, the other one is path B. Initially, it may be going via this path because the link is just only one link to reach router C. But later, when this link goes bad, automatically the routing table will erase this route. It will erase this route and put this route. See, when you do static routing, it will take a long time for you to realize the path A has gone down. See, path A has gone down. You have written a static route saying go this way to reach 192.168.0.1. This is going to take a long time if someone complains you. If this guy, if Mr. A tells you that I'm not able to ping C, A is telling you I'm not able to ping C, then you will start checking what happened. After which you will come to know the path A is gone down. There is a link failure. And now what you will do is you will erase the old static route, and now you will write another static route so that the path will be this path. But for doing this, it will take time. What if you are busy on that day, you cannot come to office? Problem, no? Assume that you are the only person in your office who maintains the network, and you wrote a static route via path A, and now path A is bad and you are not in the office. What will happen? Everyone will report against you. See, the network is very bad, the administrator has not come. The management will fire you. Management will not know that this is one small problem. For them, it is a big problem. For you, it is a small problem, just one static route. But for them, it's a communication breakage between the employees. They are not able to work. So, we need an automation. We need this to be automated. This can be automated using dynamic routing protocol. So dynamic routing protocols are to discover the best route. You may have multiple routes. Discover the best route. One thing. Secondly, if the best route goes bad, find the next best route and remove the old route from the routing table and put this second best route. Because the very first best route is no more available. It's gone. So dynamic routing protocol saves your configuration time, saves your manual work. If something goes wrong, convergence also happens very fast. What is convergence? Can you explain convergence? Okay. Convergence. But do you understand what I mean? Convergence? No? Convergence is faster means you're going in a bike. You started here. Wait. You started from this point and you're going. In your mind, you are thinking that I will go via path A. But when you reach here, you found that path A is broken. Immediately your mind says go this way. That is convergence. Now define what is convergence. Convergence is changing the path when the desired path goes down. When the desired path goes down, changing the path to an alternate path immediately without anyone's help is what the routing protocol can do. So routing protocol can converge faster. Routing protocol can converge faster. What does it mean? If one path goes down, immediately it picks the alternate path. If the path A comes back, what will happen? Again convergence. It will put back the traffic into path A. From path B, it will put the packet to path A. You understand what is convergence?
Yes, sir.
So routing protocol helps to discover route. After discovering the routes, it puts the best route into the routing table. If the best route goes down, it immediately finds the alternate path and puts the traffic in the alternate path, which takes less time for the convergence. It is going to dynamically learn the routes and put the route into the routing table. That's what I said, no? Now you see, I'm going to remove all the static routes and enable a dynamic routing protocol to show you what dynamic routing protocol can do. See, right now I have a default route. I remove this. Sorry. Say I remove this. Likewise, I will also remove from the other routers. So I removed all the static routes. You see there is no route, show IP route. Is there any additional routes other than connected? No. Likewise, on B router, is there any additional route other than connected?
No, sir.
On A router, is there any additional route?
No, sir.
Okay, you see, I'm going to enable a protocol called RIP, router RIP, network network. You see, router A knows about these two networks, correct? Because they are
Yes.
directly connected. I'm just telling only those networks. I'm not telling 192. Understand? Understand? I'm not talking about this network. This network is not in router A. I'm telling only about 172 network and 10 network, which is in router A. So I'm talking only about those two networks to the routing protocol called RIP. And then hey, what are the networks this router knows? You need to immediately respond. I don't know why you are not responding. See?
10, 20, and 80.
Yeah, that's all. When I was teaching the first router, you should be ready with the second router. Fine. You understood what to do. Now router 3 knows only about these two networks.
20 and 192.
That's it. Well done. Now we have enabled RIP. You see, you will be surprised to see the first point that I was talking to you. What is the first point? Routing protocol discovers the route dynamically and put the route into the routing table. You see now, show IP route. Wow. You see,
Yes, sir.
it has discovered the route and it has put into the routing table dynamically. You will see that on every router, even router C, you see. You can see that.
Yes.
Even in router B, you see. So router B has got 192. What about 172? Still it has not come. Maybe it will take some time. Router B has not learned about 172. Why? We'll check. Something is wrong with router A. In router A, when I advertised, I put wrong one. Look at this. What should I put here? What should I put here? 16. Yeah?
Yes, sir.
I just put 172. That's why I didn't advertise. Router RIP. No network 172.0.0.0. Network 172.16.0.0. Now you will see. Let us go to router B and check. B earlier it was not having 172, now it will have 172. You see. Now C will also have 172. Earlier you were not having 172, but now you see it is advertised. The networks are advertised to all the routers and they all have the route to reach. You understand?
Yes, sir.
So the simple command that I used is this one. Use this as a sample, okay? Are you listening? Use
Yes,
this
sir.
as a sample. In your lab, now you remove all your static route and do this and see. I'll come and teach you this routing protocol RIP. First you finish this lab. You don't know what is RIP, no problem. It's one protocol I'm going to teach you, but this is how you configure RIP. Why you should not advertise 10 network in router C? Because router C don't know about 10. Router C is not connected to, is router C connected to 10? No. It is only connected to 20 and 192. That is why in router C, I have 20 and 192. I'm not talking about 172 or 30 network. Do you have any doubt in configuring?
No, sir.
Now, so we saw a sample of how a dynamic routing protocol can learn the routes dynamically, install the route into the routing table. Some of the routing protocol that are widely seen is RIP, which is the one which we enabled on our router. The name RIP stands for Routing Information Protocol. Mute. Routing Information Protocol. Secondly, EIGRP, which is Enhanced Interior Gateway. Or gateway, I just write RP. RP means routing protocol. Enhanced Interior Gateway Routing Protocol. Third one is OSPF, Open Shortest Path First. Open Shortest Path First. There is also another protocol called ISIS, Intermediate System to Intermediate System. IS means Intermediate System. There is another routing protocol called BGP. Right? So these are all the well-known, popular routing protocol on earth. These are all the routing protocols that we have. Now, out of this, the first four comes under a classification called IGP protocols. IGP stands for Interior Gateway Protocol. IGP, Interior Gateway Protocol. And this one protocol is what called as EGP protocol. Exterior Gateway EGP protocol. In this course, we'll be learning about these three to a CCNA level. These protocols will repeat again in CCNP as well as in CCIE. This will come only in CCIE, and this will come in both CCIE and CCNP. Anyway, our focus is mainly on these three protocols. They come under the classification IGP. What is IGP? What is Interior Gateway Protocol? The protocol that's supposed to be within an autonomous system. Within an autonomous system. What is an autonomous system? One organization is one autonomous system. The network inside one organization, one enterprises, one organization is what? One enterprises. One enterprises is what? One autonomous system. All those routers work for that company. So there is one autonomous system. Then what is EGP, exterior gateway protocol? What is it? It is the protocol that works between autonomous system. Between autonomous system. Right? Interior gateway protocol, exterior gateway protocol. Right? This is how we classify the protocol. So in our next class, we are going to focus on this first protocol, RIP. You just enable RIP, but we have to learn systematically this protocol, and then we'll move on to next protocol. So tomorrow is going to be RIP day, routing information protocol. See you tomorrow.